Welcome to Electrical Safety for Electrical Cords. Janus uses extension cords, power tools with cords on them, power strips, GFCIs on every single job we do. If extension cords, or power strips are not kept in good condition, there's a potential for the cords, the tools, and the power strips to stop working. If we damage the exterior insulation on the cord, water gets inside, it could cause the cord to short, or it could cause an electrical problem. Replacing a cord is a waste of time, but more importantly, the electrical hazard could be an electrical shock to you, or it could start a fire in the building that we're working in. The potential for electrical shock is significantly increased by the fact that Janus works in wet environments whenever doing asbestos, lead, silica, or even regular demo work. We keep the materials wet in order to keep the particulate matter out of the air. That increases the potential for electrical shock. Some very basic rules here. Cord strips, power strips have to be inspected for damage before use every single time. You do this inspection, but don't use this particular cord because it does have that section there where the exterior insulation on the electrical cord is missing. Power cords cannot be repaired with duct tape, and power cords cannot be repaired with electrical tape. Electrical tape is a temporary fix that won't work well for the type of work that we're doing. Silver duct tape should never be used to repair an electrical cord because silver duct tape conducts electricity. So don't do either of these things out in the field. These field repairs are not safe and are not acceptable. All cords that are repaired need to be repaired back at the shop. When we do repair a cord, we have to cut out the section that's been damaged, shortening the cord obviously, and then reattach the plug head with the insulation going into the casing of the plug. When we do remove a plug from the power source, we want to make sure that we grab the plug and pull it out of the socket, directly holding onto the plug. You never want to yank a cord out of the socket. It's not so much that the prongs will stick in the power outlet or something, but it could pull the insulation loose from the plug itself, causing the same type of problem that we talked about before, where the insulation and the plug no longer reach each other, exposing the individual electrical wires. You never want to overload a power strip, a power outlet, or a temp power spider box. You see on the left here a power strip. It's got far too many electrical plugs coming out of it, electrical cords coming out of it. It often ends up making the device look something like this, where it's gone through a fire. The outlet in the middle has the same type of problem. This one's on a wall, and that can lead to this type of a problem where the wall actually catches fire. The electrical cords catch the wall on fire. Those are the spider boxes. They can handle more cords than your typical power strip or power outlet. Each individual plug into a spider box is GFI'd separately, and it should prevent you from overloading the circuits, but it can happen, and the spider box will end up looking like this. One of the things you want to make sure that you do when you're using an electrical cord or any electrical outlet is assure that the electrical outlet or the electrical extension cord is wired properly. It could be that the power outlet could pass this testing, but the electrical cord itself can't because it's been wired incorrectly, or sometimes the wires inside the electrical cord have broken. With this testing plug, you plug it in, and as different lights show up, it tells you whether or not you have a properly working outlet, a properly working electrical flow, or if there's a problem. This one, where the lights are on in the center and on the left-hand side, it would indicate that the neutral wire and the hot wire have been reversed somewhere. That can cause a lot of problems when tools are expecting the flow of electricity in a certain pattern. You can have reverse polarity. It can cause problems for your tools. And this one, the circuit has an open ground. That means that the electricity can't get back to the ground in the fashion in which it is designed, which means that if you come in contact with the electrical flow, you can become the ground. That is not a good thing. Electricity passing through you is a problem. Okay. This electrical tester is in a power outlet that is properly wired. Okay. The middle light and the light on the right are lit. This one is ready for use. Okay. All tools, power cords on tools, extension cords should have a ground fault circuit interrupter somewhere in the electrical train. The ground fault circuit interrupters that we use a lot at Janus are on the left here, and then again the spider boxes are all GFI'd. Ground fault circuit interrupter, if anything goes wrong with the expected electrical flow through the cord or to the tool, the ground fault circuit interrupter breaks the system and power is no longer supplied to that electrical cord or to the tool. Ground fault circuit interrupters need to be the device closest to the power outlet. Okay, so you plug the ground fault circuit interrupter directly into the power outlet, then you plug the extension cord in, and then you plug your tool into the extension cord. Some people put the extension cord directly into the power outlet, then run that extension cord to the GFI, and then plug the GFI into the extension cord and the tool into the GFI. In this situation, if something goes wrong with the power flow, the electrical flow through the GFI to the tool, the GFI will break and shut the power off, but it only shuts the power off from the GFI to the tool. If you go back and unplug and replug the GFI in, you're actually handling an extension cord that has live power in it. If the extension cord was the problem, that problem could become something that impacts you. Make sure that the GFIs are the device closest to the source of power. Some electrical devices only have 2 prongs instead of 3. The grounding prong is missing here. This does not mean that you can use a 3-pronged electrical plug and break the grounding off to put it into a 2-slotted electrical outlet. If the ground rod is not there, the grounding prong is not there on a plug, do not use that plug. Some devices are designed without that. These devices most often have 1 prong that is actually a little bit wider than the other prong. If you look at the outlet that's pictured here, the slot on the outlet on the right is somewhat wider than the slot on the left. That assures that the 2-pronged electrical device receives power in the fashion that it is expecting. If you were to force the plug into this outlet, just push it in there as hard as you can, make it fit, even though the prongs are not designed to fit that way, you would again reverse the polarity of the electrical flow, and it can cause problems for the tool. And one last thing, you never want to plug into the wall through silver duct tape. Silver duct tape is electrically conductive, as we've stated. Plugging through duct tape will allow the duct tape to impact the prongs, which will allow the electrical current to enter the duct tape itself, could shock you, could start a fire in the wall. Even if it's a situation like you see here, where the slots for the plugs are open, they could come in contact, the duct tape could come in contact with the prongs of the plug. So with that, we're done with electrical safety for electrical cords.